Hello, and welcome to learning React.js. In this section, we'll talk about the powerful design concepts behind the React library, and we'll discuss the reasons behind them. We'll learn some details about the way React implement those concepts, and put some focus on the React virtual DOM and how it works. Let me first give you a quick introduction about React. React is officially defined as a JavaScript library for building user interfaces. Let me point your attention to two important things in this definition. First, React is a JavaScript library. It's not a framework, React is not a complete solution, and it does not make any assumptions about any other parts that you need to use in your system. React is just one part that we can use in any JavaScript-based application, and we'll often need many other parts to complete the application. This is very different from frameworks like AngularJS and Ember.js, which mostly control all the parts that we need in a front-end application. Those big frameworks have strong opinions and they made many design decisions for us. React, on the other hand, is designed to do just one thing, and we'll often need to make our own design decisions around that thing. The one thing that React does very well is the second part of the definition, building user interfaces. Note that the definition didn't say web views or HTML markup. We're talking about user interfaces here in general. A user interface is anything you put in front of a user to interact with. This includes, but not limited to, web applications, mobile applications, the touch screen on a modern car dashboard, or a fancy printer, or even on a fridge. What we'll learn in this course is how to use React in a browser to build HTML-based user interfaces. But don't limit your thinking of React to just that. React can be used outside of the browser in many other ways. React is a small but powerful library, with the power being more in the concepts and design than in the implementation. Some of the strongly related concepts under which React operates are reusable, composable, and stateful components. We build user interfaces in React using components. Here's a sample component output for a simple view, an image that we can click. We can give this component the informative name clickable image, and every time we see this clearly named component in the code, we know exactly what it is. Every React component has properties. Those properties can be compared to HTML elements attributes. We can think of React components as custom HTML elements. We don't have a clickable image HTML elements, but with React, we can define all the custom elements we want and use their readable names instead of using the limited HTML elements set. Using readable names makes working with our code easier for others. We can reuse a React single component in multiple places with different properties, just like we can reuse HTML elements with different attributes. We can build bigger components using smaller components, and we can mix React components with HTML elements to compose other components. Every component in a React application also has a private state that may change over time, and React will take care of updating the component's view when its state changes. We'll cover this concept in details when we talk about the React virtual DOM. For now, remember that React components can be stateful. Think of the state as the content that drives a certain view. For example, if we have a view that displays the latest update that happened on a wiki page, whether that update was an actual edit or when someone commented on that page, this particular component depends on two state elements: the last updated timestamp for the wiki page itself and the creation timestamp for the last comment on the wiki page. When any of those two state properties change, the view needs to change as well. This is where the second React concept comes in handy. React's name is the simple explanation for this concept. When the state of a component changes, those changes need to be reflected somewhere. For example, in the wiki page last updated view example, when we receive a new comment, we need to regenerate this timestamp view and tell the browser to replace its old content with the new content that we just generated. With React, instead of us manually instructing the browser to do this update, React will execute this task for us automatically. We don't have to worry about it, and we don't have to invest the time and effort needed to make this rendering process work for all the different browsers in an efficient way. Efficiency is the third concept that's worth talking about here, which React achieves using the virtual representation of views in memory. With React, we write HTML using JavaScript. We rely on the power of JavaScript itself to generate HTML that depends on some data, rather than enhancing HTML to make it work with that data. Enhancing HTML is what other JavaScript frameworks usually do. For example, Angular extends HTML with features like loops, conditionals, and others. If we are receiving just the data from the server with Ajax, we need something more than HTML to work with it. So it's either using an enhanced HTML or using the power of JavaScript itself to generate the HTML. Both approaches have advantages and disadvantages, and React embraces the latter with the argument that the advantages are stronger than the disadvantages. Using JavaScript to render HTML allows React to have a virtual representation of HTML in memory, which is aptly named the virtual DOM. And React uses that to render the views virtually first. Every time a state changes, and we have a new HTML tree that needs to be written back to the browser's DOM, instead of writing the whole tree, React will write only the difference between the new tree and the previous tree, since React has both trees in memory. This process is known as tree reconciliation, and I think it's the best thing that has happened in web development since browsers started supporting Ajax.